Hello everyone, welcome to CyberCrete, and today in this video we are going to start our new data science series. And in this series we are going to see the mathematical parts of the data science as well as also the practical part. The goal of our course is to just make a perfect balance between the mathematical concept as well as the practical concept. So for every term that we are going to learn mathematically, we are also going to implement it using programming languages. So like this, we can get the complete and clear understanding of what all those machine learning algorithm internally does and how they work. So today in this video, we are basically going to start with the most common dataset, that is iris dataset. And in this video, we are going to discuss the mean, median, mode and how they are important. First we will discuss using the inbuilt library, and then we are going to code this mean, median, mode by ourselves. So let's just start this video. Okay, so the first thing with any data science lifecycle is to just load the data or basically get the data. So the link of this iris dataset will be given in the description below. You can just go ahead and download it from there. Okay, here are some of the libraries that we are going to need. So first one is pandas, which is basically used to read the data that is in any format, like it is in CSV, it is in SQL, or it is in any format. The pandas is the data frame that is basically going to read the data. And then we have the numpy, and numpy is basically used to manipulate array, and we are going to use it to find mean, median, mode just quickly because it comes with predefined function. But then again, we are also going to implement those functions to get more clear understanding. So we just have imported some of the libraries that we are going to need, and then here is the link of iris dataset. I have provided it here, and I will just provide this Jupyter notebook too. And then we are saying iris is equal to pd dot read CSV. So this read CSV function basically allows us to read the CSV file. So before moving on to our mean, median, mode, first let us just have a quick overview of this dataset, of like what is this dataset all about. So in the first, we are basically printing the shape of the dataset. So shape means how many columns or how many rows we have. So here it is row into column. So we have total 150 rows and 5 columns. And now let us see what are those 5 columns. So the 5 columns are sepal length, sepal width, petal length and petal width. So it is basically a iris data set, and iris, if you don't know, is basically a type of flower. So here you can see iris satoshi, this is one category, iris versicolor, this is another type, and this is iris virginica, this is another type. And what are those features? Like here you have seen that sepal length, sepal width, petal width and species. So species is iris satosa, iris versicolor, iris virginica. So these are all the species, and other features are like petal length. This is petal, this is basically our petal, and this is our sepal. So this is sepal length, sepal width, petal width. So these are all the categories that we have inside our data set. But let me just go ahead and insert a new cell below, and let me show you how this data set looks like. So to view any data set, we can just say iris dot head, and here we can see how our data set is basically displayed, like sepal length, sepal width, petal width, and here it is basically saying what species of the flower does it have. So the next thing we are simply doing is iris species dot value count. So here we are counting like how many types of satosa we have, how many type of versicolor we have, how many type of virginica we have. So here we just get like we have all of them in equal number, 50 50 50. And now let us see what is mean, median and mode with the help of this data set. So here what I have done, here I have just distributed the data set into 3 parts. First, iris satosa, all those flowers that are having the properties of this satosa are in our iris satosa. All the flowers that are having the properties of virgicolor is in virgicolor, and all those having the virginica are in virginica. So let me just quickly go ahead and let me show you how does this look. Insert cell below, and when we just simply run this, you can see that all the flowers of satosa are inside our iris satosa. So we have done this just to make our program a little bit clear and more readable. So once we have that, we are finding the mean. So So first of all, let us just simply understand what does mean do. So mean is basically the average. Like in mean, what we basically do, we just sum up all those elements in our data set and then divide it by total number of elements inside our data set. So let me simply write it. So the mean is basically represented with this symbol of mu, and mu of the petal length or any data set is nothing but it is the summation over I from 1 to n, and then we are basically trying to find xi, means we are basically summing up all those elements in our data set, and then we are simply dividing it by total number of our data points. So here n is total number of data points, so it is basically like writing x1 plus x2 plus x3 and so on and so forth, and then dividing with the total number of x in our data set, and let us just say it is n. So this is how we mathematically write it, and this is how it basically looks. So our summation, which is basically telling that we have to sum up all those xi elements. So here it is xi, we are basically summing up all those elements and then we are just multiplying it by 1 by n, which is just basically dividing by total number of elements. So what important role does this mean play? Understanding this is the most important part, because you already have studied the mean median mode in like 10th or 12th grade, but here we are going to see why it is more important. So here you can see that as soon as we print the mean of all those flowers like Satosa, Varjika and Versicolor, we can simply see that it is giving some types of value. And by seeing this type of value, we can see that the petal length of our Satosa is less than our Versicolor and Virginica. So by just looking at this mean, we can basically say that if the flower is having less than 2 or it is less than 3 also, you can say, then we can classify our flower as Satosa. So without any algorithm, without anything, with just a simple if statement, we can basically conclude that any flower that is having the petal length less than 2 is going to be in iris Satosa. And this is why this median is so important. And one more, so what does this median is basically trying to tell us is that this is basically the central value, or this is basically the average value in which all our data points are basically going to lie. So by just looking at this, we can simply build a simple model that is basically going to detect all those Satosa flowers without any heavy mathematics, just with an if-else statement. But this mean have one great disadvantage, that it gets completely changed with a single outlier point. And what is an outlier, you ask? So let me explain. So let us say that you have numbers like 1, 2, 1, 2.5, 3.5, and then you have a number like 90. So here now 90 is an outlier. So what does outlier mean? Any number that is not lying in the series of the data set. Like it can be either a very large number, like here we see 90, or it can be very small number like minus 10. So here both these numbers are outliers. This 90 and this minus 10 are both outliers. These are the data points that does not basically fits inside the data point. And then let me just simply show you with just adding an outlier in our iris dataset of petal length of 80. We just simply add another xi point which is having 80, and just because of that our average is getting deviated so much high. So you can see that the mean was just 1.464, but with a single change, just a single change in out of 50 data points, we are getting like from 1 we are simply getting 3. So here you can see that how much impact does an outlier play in our mean. So with just a single outlier, our mean is going to just fail. And you can see the same with the case of petal length and petal width. All are getting from 5, it becomes 7, for 4 it becomes 5. So by just a single change in our data point, we are getting completely change in result, and this you can say that it is tremendous change in the result, because like with the simple change in the data set, now we have to say that any flower having 3 or more are going to be in our Satosa, but that is not the true, because this outlier point is not correct. So how these outlier points generally occur? This is the big question. So let us say that you are just entering the data and other people are entering the data in the form of centimeters, and then you just insert the data in the form of millimeters because you don't know what was the field. So just because of this miscalculation, you are going to have an outlier in the data set, and that is going to cause tremendous impact on your entire model. So that is why we have to just treat the outlier and remove the outlier. So there are different methods for that, but for now we can basically see that the outlier is causing some great trouble to our mean. So in order to escape this outlier factor, we have another important concept in our statistics, that is our median. So let us see that median. So here I just wrote np.median. So this is all inbuilt function in our numpy array, which is basically responsible for finding mean, median and other different types of calculation, and that is why we are going to use numpy, but we are also going to implement it in a while. But let us just see first. So here we are finding the median of the Satosha, and here of verticolor and versicolor. So here we can see that the median is not greatly deviated as the mean. So mean and median are approximately close to each other, but things get changed when we are going to use outlier. So here we wrote the same code by adding some outlier, like here we added 80 as an outlier, here we also added 80, and here we also added 80. The thing to note here is that our dataset of Satosha from 1.5, it is still 1.5. It has not changed a bit even we add a number like 80. And here in our dataset you can see that the number are in decimal form like 3.5, 4.5, but when we added a great number like 80 in our median, the median does not change at all. But in the next case it changed slightly, like from 5.55 it becomes 5.6, but this is not a great change. So this is not going to impact our model as much as our mean does. So in mean what happened, from 5 it became 7, means it is just increased by 2, but here in our median case it is just increasing by 0.1%, so it does not cause much change in our data set. And then we are simply going to find the median of this petal length, and with an outlier, so it is from 4.35 it just became 4.4, so it is just 0.5% increase. So as you can see that median is less impact from the outlier. So if we are trying to deal with an outlier and you know that there is outlier in our data set, then try to use the median. So what is median? Let me show you. So median is nothing but it is the middle value of your data set. So let us say that you have numbers like 1, 2, 3, 4 and 5. So if you are trying to find the mean, you are simply going to sum up all those elements and then divide it by 5. But when we are using the median, we are just picking up the middle value. But to find the median, the first and the most important thing that you should always remember is to first sort. So first basically sort our value. Please don't forget to sort, because if you are not going to sort median, then you cannot find median. And sorting is just independent. Either you sort it in ascending order or you sort in descending order. It is not going to have a great impact. But here we can see that the number are in odd, the total number of elements are the odd number of elements, and then we are simply able to find and pick up the middle element. But what happens when we don't have the odd number of elements? We have even number of elements, like we can say that we have 1, 2, 3 and 4. So in this case, when you have even number of elements, you know that the middle element is just somewhere here, but there is nothing like that. So you pick one element from here and one element from here. So we pick 2 and 3, and then we are just going to sum them up, and then we are going to simply divide it by 2. So we are going to just say 2 plus 3 is 5, 5 divided by 2 is 2.5, and you can see that 2.5 is dividing this number in equal halves, like 2.5, anything that is less than 2.5 is in this side, and anything that is greater than 2.5 is in this side. So this is how the median comes to play a role. And let us see why this median is not impacted with our outlier. So let us have an example. So let me show you. Let us say we have numbers 1, 2, 3, 4, 5, and then we have 79. 1 2 3 4 5 and then 79. And you know, when we are trying to find the median, then the first step is basically to sort our array. So we have sorted our array, and that is why this 79 is at the very last of our array. And if any number that is an outlier, if it is a great outlier, then it will be at the last, and if it is the minimum outlier, then it will be the first. And what we have to deal with here, we don't have to deal with either the first element or either the last element. We have to just deal with the middle elements, and that is the reason why our median is not impacted by the outliers, because we don't have to look at the largest value and we don't have to look at the smallest value. We have to just look at the median value. So here the median will be total number. First we have to count if our array is in odd or in even. So here 1 2 3 4 5 6. So we have total 6 number of elements, so we are just going to pick these two, 3 and 4. So we can see that 1 2, and here we can see that we have our 5 and 79. So we pick 3 and 4, we just sum them up and divide them by 2 and we will get our answer. So we just get 7 divided by 2, and when we are going to divide, we are going to get 3.5, and this is our median. So this is how we basically find median. And till now I think that you have basically known that why this median is not impacted by outliers. So let us move forward. So the same purpose that our mean does is the same thing that our median also tries to do, but without getting highly impacted by any outlier. By the help of median also, you can basically say that 1.5, anything that is like 1.5 or 2 or less than this is basically going to be Satosha. Without using any logic or without using any machine learning algorithm, you can basically classify this as a Satosha flower, and the same with his Virginica and with versicolor. But here they are both are close to each other, so we might need to have some model. But now the last thing that is left here is our mode. So what is mode? Mode is nothing but it is just a frequency. So let me explain you. So what does the mode says? So mode basically tries to find the most occurring value. Let me show you. Like we have our numbers 1 2 2 3, then we have 4 4 4, then we have 5 and 6. So what does mean tries to tell us? Which is the number in our data set that have the most frequency, or which is occurring most often. So here we can see that 4 is occurring 3 times, 2 is occurring 2 times, and all other numbers are just occurring single time. So the mode of our this list will be 4, because 4 is the number that is occurring the most. So that is the function of this mode. So mode is also used in many different places in machine learning that we are going to see in future, but for now you are basically got the idea what this mean, median and mode does. And now it is the time to basically implement what we have learned inside our code. We are going to have a look at the mean code, median code and the mode code as well. So let's just start. So let me show you. Here I wrote a simple function of the mean. So what does mean tries to tell us? If you remember, in mean we are basically trying to first find the n. So it is basically all the xi's. So it is just the summation of all xi's from 1 to n, which is basically multiplied by 1 by n. So this is our mean. So first we need to find this n. So we found the n by finding the total number of elements in our array. So that is basically n, and then we are finding the mean. So here we wrote sum of ARR, which is basically this. It is equivalent to writing this. Sum of ARR, it is basically going to find the sum of each and every element in our data set. So if the elements is like 1, 2 and 3, it is basically going to sum up 1 plus 2 plus 3, it is basically going to return 6. So then we are dividing it by n. So this is the same thing that we are doing here. We are just dividing it by n, and n here in this case is 3. So we are going to get 2. And like this we have simply implemented this mean function by ourselves. So now let us have a look at the median function. In median, let me change the color. In median, first, as I told, the first step is to basically sort the array. First you need to sort. So first of all we took our array, we found out the length, that is basically n, and then we are basically sorting our array. We sorted our array in an ascending order, and then we are trying to find the middle element of our array. So if our array is something like 1 2 3 7 5, so the first step we are going to do is to sort this. So after sorting, it will be 1 2 3 5 and 7, and then we are finding this mid is equal to n by 2. So what is n? N is total number of elements in our array. So n here is 1 2 3 4 5, so n here is 5. We can simply write it here somewhere like 5, and then we are simply saying mid is equal to n divided by 2. So we are simply double dividing by 2. So what does double divide do? So if we are trying to just use a single dividing sign, it is basically going to return a decimal value. So if we are just using 5 divided by 2, then it is going to give the value that is 2.5. But when we are going to use this double dividing sign, it is basically going to return an integer value, which is 2. It is basically going to round off our value, so it basically round off to 2. So that is why we are using double slash to just get an integer value. And then what we are doing is we are simply checking if we have odd number of our elements. So if n modulus 2, in this case we have 5, so if 5 modulus 2 is equal to 0, means if we are not writing anything, 0 is as default, you may know 0 means false, ones mean true. So if you are getting 0, which means then do not execute this. So if we are getting 1, means we are getting a remainder after finding the modulus, and when we are getting the remainder, then we mean that our number is odd, like 5 modulus 2. So what we get after doing this 5 modulus 2, so it is going to give us 1, and 1 means true, so it is going to just click in our array. And then what it is going to do, it is just going to pick up the middle element of our array. So if it is 5, it is going to be 2 5, the middle is basically 2, as we have seen here, middle is equal to 2. Then the indexing of our array start from 0 1 and 2, so it will pick our 3, and of course 3 is our middle value, 1, which is basically dividing this in 2 equal halves. And what happens when our array is not in even, when it is odd? So let us say that our array is 1 2 3 and 4, then it is going to take the middle element. So middle of this is 2, so it is also 2, because we have total 4 elements, and when we are double divided, we are going to get 2. So we pick our 3 first, and then we subtract it by 1, because we want to take this value 2. So we subtracted it, and then we found out the second value as 2. So we are basically going to sum them up, which is basically 3 plus 2, and then we are going to divide it by 2, and then we are basically going to return, because this is our median. So let me just clear this. And the next thing that comes is mode, which is basically counting the frequency. So when we are trying to count the frequency, the first thing that we are going to use is our dictionary. So dictionary is basically going to keep a track of the total number of occurrences, like how many times one occur. So let us simply say that our numbers are 1 2 2 9 4 and 5. So it will take a count, like 1 it is occurring 1 time, 2 it is occurring 2 times. So dictionary is nothing but a key value pair, and if you know nothing about dictionary, you can basically refer it in our Python playlist, where I have explained how to use dictionary in Python. And if you have ever learned any other programming language, you may know it by the name of hash map or hash table, depending on the programming language of your choice. So the first thing we do is just to count the frequency of every element. So like we are counting here, and 9 is 1, and after this we would have got this. And the next thing we are going to do is to find the maximum number of frequency that is in our dictionary. So we just use a max function to find the maximum frequency, and here you can see that the maximum frequency is 2. And then we are simply going to loop through our array once, and we are going to simply print the number having the maximum frequency. So here we are going to print 2. And what happens when there is number, all the number have the simple frequency, like every number occurs once, 1 2 3 and 4. So in this case, either you have to say that there is no mode, or you are going to say that all the numbers are the same mode, or you are going to just ask your interviewer or ask the question that some of the questions basically try to tell us print the smallest number or print the greatest number. So like that you can basically make the change in our code. Now let us just test our function, like if they are working or not, because if you are not going to test, how you can say that this program is working fine? So here I simply wrote a simple array, and this is our array of 1 2 2 3.9, and then we are finding the mode. So mode, here you can see that mode of 2, because 2 is occurring 2 times, so we have our mode as 2, and then we are just simply printing all of these like mean, median, mode on our this array. So we got the mean as 4.14, median as 4. So here when we sort this element, we got 1 2 2 4 5 6 and 9, and we can see that the 4 is the number that is dividing our numbers into equal half. So the mode is, median is 4 and the mode is 2. So our program is working perfectly fine, and by this we are simply going to end this video. And by the help of coding and the mathematical concepts, you can see that how clearly we can understand any topics. Just try to learn some mathematical concept and then try to implement it in the programming language of your choice. And by this, you can just strengthen the knowledge of both your programming language as well as the mathematical concept. So this was all for this video, and I hope that you like this video. And if you have any doubts, you can just basically ask in my Telegram group or in my Discord server or anywhere, or even inside the comment section. And please do not hesitate to ask any doubt. Your doubt will also help us to learn new things, and we will try to help each other. So if you like this video, please make sure to subscribe to our channel, hit that bell icon, and don't forget to just press that like button. So thanks for watching.